We ended the previous lecture by redoing example 26 on our financial calculators. So in this lecture, we are going to continue by doing examples for simple annuities. Annuities are often deferred in such a way that the first of a series of regular payments only begins at some time in the future. A common example is a hire purchase agreement where the first payment is made, for example, only 3 months after securing the funds for the purchase. So we are going to illustrate this deferred annuity by looking at example 28. A final year student borrows 10,000 rands for study fees from a lending institution at an interest rate of 24% per annum compounded monthly. The student will only be able to begin the loan repayments exactly 13 months after the loan is granted. Determine the value of the payments, assuming the lending institution would like to have it repaid in 18 equal monthly installments. So we can illustrate this example with the following timeline. The student gets a loan of 10,000 rands. She can only start paying after 13 months. So the first payment will be at time T13, and the student needs to pay it back in exactly 18 payments. So if we take, or the last payment will then be done at time T30. So if you take 13 plus 18, you get 31. But because the first payment is already made at time T13, if you count 18 payments, counting the payment at time T13, then you will get up to time T30. Now you will remember when we started with annuities, we said that an annuity starts one time period before the first payment is made. So if we look at this timeline, it means that our annuity starts at time T12 and it ends at time T30. So to be able to use our annuity formulas, we can only start at time T12. So what we will need to do for an example like this is we will do it in 2 steps. The first step will be to move the 10,000 rands from time T0 to time T12 and then use that value as the present value for an annuity that starts at time T12. So the first step, or we can do it on the next page. So for step 1, we will move the 10,000 rands from time T0 to time T12. I will call that future value at time T12. And now I use the formula that we've been using for compound interest. So the future value is equal to the present value, which in this case is 10,000 rands, 1 plus the interest value time to the power n. So my interest is 24% per annum compounded monthly. And we have 12 months. So that then gives us 12,000 rands, 682. Okay, so that means that the value of this loan at time T12 is equal to this 12,682 rands. And we will now use this value here as the present value of our annuity. Okay, so that then brings us to step 2. Okay, so that was step 1. And step 2, we are going to work with the present value formula for an annuity because we have the present value of the annuity. So again, what is the formula for the present value of an annuity? That formula. Okay, so that's the formula for the present value of an annuity. In this case, I have the present value, I have the interest rate, I have the number of payments, and I would like to get the value of the payments. So we can take present value and divide it by this whole factor here to get to the payment. So we would like to solve for the payment. We can take present value divided by this factor. It's the same as to say it's the present value, and then we multiply it with this factor to the power -1. So that's the factor, and I take it to the power -1. And now I can just do my substitutions. So I can now continue with my substitutions. The present value, which I calculated in the previous step, my effective monthly interest rate is 0.02. I have 18 payments. And remember, all of this to the power -1. Okay, so to settle the debt, the student will need to make 18 equal payments of 845 rands and 94 cents, starting 13 months after securing the loan. Okay, so now we will continue to example 29. Mr. Pasi is planning to purchase a holiday home in Port Alfred. A loan of 400,000 rands is secured at an interest rate of 21% per annum compounded monthly. And he needs to repay this loan with equal monthly payments over the next 20 years, and the first payment falling due 1 month after securing the loan. Find the value of the payments. Okay, so when you get an example like this, first of all, you need to recognize it as an annuity. And it is an annuity because he needs to repay this loan with regular equal payments. So that's the first thing. The second thing is to recognize it as a simple annuity. It's a simple annuity because the compounding period is monthly and the payments are also monthly. And then lastly, we need to determine whether we are going to use the present value formula or the future value formula for an annuity. Now in this case, because we are working with a loan, we have the present value, we have the 400,000 rands, so we will work with the present value formula for an annuity. Okay, so we start again with the general formula for the present value of an annuity. And we would like to find the payments. So this is similar to the previous example. To find the payments, I have the present value and all of this to the power -1. That is the same as to take the present value and dividing it by that factor. And now we do the substitutions. The present value, the loan size, 40,000 rands. The interest rate is 21% per annum compounded monthly, so that's 0.21 divided by 12, or you can just write it as 0.0175. And the number of payments, we are working with monthly payments for 20 years, so it's 20 times 12 to give me 240 payments, so it's minus k is minus 240, everything to the -1. And if you do the calculations, you get to the value of the monthly payments.